Hello everybody, in this video we are going to discuss about the first come first served scheduling algorithm, which means that the items from the queue are processed in the sequential order. This is one of the simplest scheduling algorithm. So let us understand this one with the help of an example. So we are considering here that there is a queue or disk queue with the request for input output services to be provided to the particular tracks. So these are the tracks like 100, 185, 40, 120, 20, 130, 65 and 80. Okay, and we are imagining that the read write head of the disk is initially at the track number 50. Okay, now because we are focusing on the first come first serve scheduling algorithm, from the initial track 50, it is going to process all the requests for input output tracks in the sequential manner, that is starting from 100 till 85. So in the first move, the disk read write head is moved from 50 to 100, followed by 185, 40, 120, 20, 130, 65 and 85. So let us have a visual look to get the better understanding of how exactly this read write head is moving. So as I have told you, these are the different tracks. Okay, so the movement of the disk here already I have taken. This is for our reference. Okay, and these are the track numbers which arrived in a sequential manner. And as we are focusing on the first come first serve disk scheduling, so these are the tracks which are processed in the sequential order. Hence, the disk movement will be something like this as you are seeing on the screen. Now, let us have a visual look. So, initially as we have considered, the read write head is at track number 50. So, from track number 50, it will move to track number 100 first. Okay, then it will move to 185, followed by track number 40. Then it will move from track number 40 to 120 track number. Then it will come back to the track number 20, because this is the order in which the request for IO came. So after processing the track number 20 for performing different IO operations, the read write head will move to track number 130, followed by track number 65 and lastly track number 85. Okay, so this is the head movement. Hope you understood how did we get this one. Fine. So now after seeing visually how exactly the movement of read write head is happening to process the various input output operations for the respective tracks, now let us see what is the total head movement happened. Okay. So this is the total head movement happened. Initially the read write head was at the position or track number 50 and then it moved to 100. Okay, so I am writing 100 minus 50. Then from 100 it moved to 185, so I am writing 185 minus 100. Okay, now from 185 track number, it is moving back to track number 40. Now since here we don't have any negative values, so I'll write here 185 minus 40 instead of writing 40 minus 185, which will give you some negative values. Okay, similarly after processing track number 40, it will move to track number 120. Again, instead of writing 40 minus 120, I am writing 120 minus 40. Okay, and then from track number 120, it is moving back to track number 20. So I am writing 120 minus 20. From track number 20, it is going to, from track number, from 120 to it went to 20, then followed by 130. So again here instead of writing 20 minus 130, I am writing 130 minus 20. As I have already told you, as we cannot have negative values here, that is the reason why I am writing the highest value first minus the lowest or the smallest value. Okay, followed by from track number 130, it is moving to track number 65. So I am writing 130 minus 65, and lastly from 65, the read-write head is moving to 85, so I am writing 85 minus 65. Now once when you calculate this value, you are getting total of 655 tracks. That means that the total movement of read-write head to process the IO request was 655. This type of first come first serve scheduling or disk scheduling algorithms can be used for small loads on the disk. Okay, but the major drawback of this one is whenever there is large amount of head movement, it will decrease the throughput. So this type of scheduling algorithm can be used for small loads on the disk. Okay, hope you people